This network has a similar architecture to that which learns a communication channel. Let me begin the simulation and start the learning. However, there are several important differences. For instance, the presynaptic population is a two-dimensional population. As before, it is driven by the input, but in this instance, the postsynaptic population is attempting to learn a function of the presynaptic population, namely, the product of the two dimensions. Consequently, the postsynaptic population is a one-dimensional population. As before, we can see the error and the connection weight matrix between the pre- and postsynaptic populations. Also, it is an identical learning rule which is being used in this circuit as was used before. That is, it is a spike timing dependent plasticity type rule which is able to incorporate error information. In the brain, we would expect error information to be generated in any number of ways. However, in these simple circuits, we are directly computing the error within the network itself. Because this is a more complicated function, it takes some time to learn. So let me pause the video and come back in a few simulation seconds. The network has now been running for about 40 simulation seconds. As you can see, the error is quite small. Consequently, we would expect it to be doing a fairly good job of approximating the product. We can examine this explicitly by turning the learning off and then controlling the inputs. If I set the input to a negative value in the first dimension and then sweep the other dimension from about 1 down to -1, we would expect an inverted sweep to appear on the postsynaptic side, which we see. Similarly, if I set the input to a positive value in the first dimension and perform a similar sweep, we would expect the postsynaptic population to have a similar kind of slope and output function, which again we see. And as a final test, we can set the first dimension to about 0, and then we would expect the input in the second dimension to have little effect on the postsynaptic response. And again, we see that this is the case.